Suppose we're asked to use the epsilon-delta definition of the limit to prove that the limit as x goes to 3 of x squared minus 2x plus 5 is equal to 8. Okay, so the first thing we're going to do is refresh our memory on the definition. Here's what it says. It's when we say that the limit as x goes to a of f of x is equal to L, what we mean is that for every epsilon, there is a delta such that the first inequality statement implies the second inequality statement. And we have to remember, of course, that when we say this, this arrow, of course, means implies, and we're saying that if this is true, then this is true. If we start with an assumption like this, then we should be able to conclude this statement here. Start with this, end with that. And again, given an epsilon, we have to come up with a delta. So epsilon is what we start from. We have to figure out what the delta would be based upon that choice of epsilon, such that this assumption leads to that conclusion. All right. Why don't we restate this in terms of the problem that we have at hand here? So for this particular problem, here's how that limit definition gets translated. We need to show for every epsilon greater than 0, there's a delta greater than 0 such that this inequality expression implies this inequality expression. So how do we actually come up with a proof here? It doesn't just come to us immediately. We have to kind of work it out. How do we go from a statement like this to a statement like this? Given an epsilon, what would the delta be so that this assumption will lead to that conclusion? Well, the way we figure these things out is backwards usually. We start with this, we write that down, and we try to work our way backwards to something like this, and then kind of figure out what the delta would be. But ultimately, when we write a proof down, we're not going to write it down backwards. We're going to write down a forwards logical argument that says, if this statement is true, this must be true. And we're going to fill in all the statements to show that this implication is true. Well, this kind of backwards reasoning is something that we do very often in life. A great example is when you're confronted with a question like this. You have to make it to a flight that leaves at 11 o'clock a.m. and you ask yourself, okay, so what time should I leave my house? We very often answer this question by working our way backwards. We say, okay, if my flight is at 11 o'clock a.m., I better make sure that I enter the airport at 9 o'clock a.m. just to give myself those 2 hours to make it through security and check in. Well, but if I have to get into the physical airport at 9 o'clock a.m., I better make sure that I park my car in the lot at 8:40 a.m. because I'm going to catch a shuttle. It might take 20 minutes to actually make it inside the building. But if I have to park my car at 8:40 a.m., it's an hour and a half drive to the airport. I better leave by 7:10 a.m. And so now I have the answer to my question. I was asking what time should I leave, and now I know it's 7:10 a.m. How did I figure that out? I kind of worked my way backwards. But my reasoning ultimately should go forwards. I really want to reason in if-then kind of statements. I want to think about what would imply what if I start at 7:10 a.m. leaving the house. If I leave the house by 7:10 a.m., then I should park my car by 8:40 a.m. And if I can park my car at 8:40 a.m., then I should be able to make it into the airport at 9 o'clock a.m. And if I make it to the airport at 9 o'clock a.m., I should be in plenty of time to make it to my flight at 11 o'clock a.m. So my reasoning goes this direction, but I kind of figured it out this direction. So very similarly, to do this epsilon-delta proof here, I want to say, how am I going to make it to this destination? How am I going to show that this conclusion is true? I work my way backwards, but ultimately, when I write a proof down, I'm going to start from this and show how it leads to this.